Good morning. My name is Hector Gonzalez Hernandez, and today I'm going to present you the solution to our problem situation about deterioration of roads. My teammates are Ivan Alonso Peña, Gerardo López Olvera, and José Mario García Bustos. Let's start with the introduction to the problem situation. Road transport is essential in Mexico, yet many roads remain in poor condition despite major investments. To address this, we developed a predictive model to estimate pavement deterioration on the Ciudad Mendoza Cordoba road. The selection of a probabilistic model approach. Road deterioration is influenced by multiple factors, such as climate, traffic, vehicle weight, material quality, among others. Many of these factors are very. The selection of a probabilistic model approach. Road deterioration is influenced by multiple factors, such as climate, traffic, vehicle weight, material quality, among others. Many of these factors are variables and unpredictables, which introduce uncertainty into the evolution of the pavement condition. For this reason, a deterministic model which assumes fixed conditions and exact outcomes is not adequate. Instead, a probabilistic model allows to represent uncertainty through transition between states with certain probabilities, better adapting to the nature of this problem. As mentioned earlier, a probabilistic approach is better suited for modeling pavement deterioration. Therefore, we use Markov chains to estimate how road conditions may evolve over time and support more effective maintenance planning. Some of the points that we consider that are the more important and why we choose the Markov process is that the future state depends only on the current condition. There is no need to track full of the history of the payment, and also fulfills the memory less of the Markov process, as well as is the ideal for modeling progressive deterioration over time.
To determine the values for each segment of the road, we have the International Roughness Index. That is the standardized measure for pavement roughness. It quantifies how smooth or rough a road is based on how standard vehicle will respond to these surface irregularities. It quantifies how smooth a road is based on how the vehicle responds and is measured using road profilers or inertial sensors mounted in the vehicles. These sensors tracks the vertical movement of the vehicle suspension. As we have a lower IRI, it's a smoother ride, and a higher IRI is a rougher ride.
Well, now, what the methodology was followed to solve the problem? In this case, to solve the problem, we first classified the pavement condition data and construct a state vector representing the initial distribution of the row segments by condition. In this case, we use excellent, good, and poor. Then we build a transition matrix using the historical data from 2016 to 2021, and then capture the probabilities of moving from one condition to another in each year. Finally, we use the matrix multiplication between the state vector and the transition matrix to project how the condition of the road will evolve over time.
So for the state vector of the first kilometer for 2022, we can appreciate that it has a 14% probability of being excellent, 65% probability of being good, acceptable, and a 20% probability of being bad. This is actually a tendency that we can observe in all kilometers. Doesn't matter if it is for 2022 or 2025. We can see the next slide. This is the first kilometer for 2025. We can also see that there is a really significant amount of probability for unstandard and acceptable state. For the second kilometer on 2022 and 2025, we can observe the same tendency. Also for the third kilometer on 2022 and 2025. And also you can see that on the 4 kilometer of 2022 and 2025.
Then we have the interpretation of the model. As we can see, thanks to the state vector, we can analyze how is the condition of each segment of the road. We can see that the Mealy condition in all the segments is a good or a great condition. But in the kilometer 275, the condition is poor, so it needs to get maintenance. Then we have that, thanks to the transition matrix, we can analyze the percentage of how it changed the condition in each segment of the road. We can see that in an excellent condition, the main change is good, with a 14%. And we can see that in good condition, the change to a poor condition is 4.5%. So that needs urgent maintenance.
Why we use these values? For this analysis, the average of IRI between the left and right lanes was used to provide a more comprehensive representation of the condition of the road segment. This shows we made it for the following reasons. First, it is a reduction of the bias caused by the damage localized on a single lane. There is lower variability, which is a more stable analysis. That's what it means. Also, there is a much more simplification of the weathering of the model and of the transition matrix. There is a global representation of the condition of the road, which is more aligned with the user experience. And also it is objective that, and also that helps to focus the overall behavior of the segments. We chose to use the global transmission matrix because if if we use it for each kilometer, it didn't predict very well some of the values for each matrix.
As you can see, here we have the two different matrices. Here at the top we have the global matrix, and here at my right we have the other transition matrix, where you can see what I was mentioning before, that some values are arranged to the number 0, which we thought that didn't predict it well how the road was deteriorating.
Then we have the general results of the model that, thanks to the 40 database analyzed to determine the condition of each segment of the road in the past 5 years, that's the result of that. In all the segments of the road that we analyze, the mainly segments that are in excellent condition or in a great condition. As you can see in the table, the roads that stays in an excellent condition and it stays in good condition, it's more than the segments of the road that change to excellent to good or good to poor. And even less that the segments of the road that get maintenance. As you can see, we can see that the states of the road that pass to poor to excellent, to good to excellent, and poor to good are more or less than the others.
Now we have the mathematical interpretation. Well, first of all, we use the Markov chains. That was the principal main to resolve this problem, to estimate the evolution of the condition of the road segment. Why we use that? Well, first of all, is to maintain a control of the condition of the road and tell if what part of the road needs soon maintenance. And then we have the part of the Markov chains, the state and the transition vector. Thanks to the transition and the state vector, it's possible that we can get the percentage of the road was in each condition in the start of the years, and how this condition has changed over the years.
For the data management and the relationship of the model, we used some values from the IRI that you are seeing now on the slides. This is helping us to determine whether the quality is going to be good, it's going to be excellent, or is it going to be bad. And also the forecast was made from 2021 to 2025. And this data process was mainly using Excel and matrix calculator to perform the multiplications for getting the forecast. As a conclusion, the most important thing that can be observed in the results for all the years as it was previously observed is that all the kilometers express that there is the high probability is that it is gonna maintain a standard state, an acceptable state. This is a tendency that we can observe in the matrices, in the resulting matrices. We showed the 2022 and 2025, and in all of them, the highest probability was that it's gonna remain in an acceptable state, which it actually means that the road is not necessarily gonna need that much of maintenance. It's gonna need no more than a little maintenance. And for the recommendations or for using the model, it would be very useful that the model gets updated frequently, because the more it gets fed with data, it's gonna be more precise and it's gonna generate a more specific and a specific forecast, and it is gonna work for generating more organization, for generating broadcasts to prevent things that we don't want to happen in the roads, and to organize the maintenance of the roads. And that would be all. Thank you so much.